Imagine you're holding an ice cube in one hand and a mug of hot water in the other. Both are water, but they behave very differently. Why is one hard and cold and the other liquid and hot? The answer is in something we can't see: the motion of the particles. Everything is made of tiny particles, atoms and molecules that are never completely still. When a material is cold, those particles move slowly. When it's hot, they move faster. In reality, heat is just that: how much movement energy those particles have. So what happens with the changes of state? In a solid, like ice, the particles are very close together and ordered, like soldiers in formation. They can't travel freely, they just vibrate in place, a little to one side and a little to the other. Now we start heating that ice. We're giving it energy. The particles vibrate harder and harder. They push their neighbors. They pull on the bonds that hold them in place. There comes a point where the vibration is so strong that this order breaks down. The particles can't stay in perfect rows anymore, and the solid turns into a liquid. In the liquid, like water in a glass, the particles are still fairly close together, but now they can slide around each other. Imagine a crowded dance floor. Lots of people, but everyone is moving, crossing paths, changing places. Have you noticed how water takes the shape of the glass? That's because those particles move just enough to rearrange and adapt to the space they have. If we keep heating the water, we give even more energy to the particles. They move faster and faster, collide more strongly, and some of them manage to escape from the surface. That's where the gas phase begins, like water vapor. In a gas, the particles are much farther apart and travel almost wildly in all directions. They hit the walls of the pot, the air, everything. That's why a gas tends to expand and fill all the space available. Have you ever seen how a pot of water goes from calm to boiling with bubbles everywhere? Those bubbles are regions where liquid water is turning into gas because the particles are moving fast enough to break free. And this also happens with your own body. If the air around you is warmer than your skin, its particles move faster, and when they collide with the particles in your skin, they pass some of that energy to you. That's heat flowing into you. When you touch something very cold, it's the opposite. The particles in your body have more energy and give some of it to the cold object. That's why you feel like you're losing heat. And when sunlight hits you, it doesn't even need direct contact. Its energy travels as light, reaches the particles in your skin, makes them move more, and you feel warmer. So to sum up, solid equals particles very close and almost fixed. Liquid equals close together but sliding around. Gas equals far apart and moving at high speed. Next time you see ice melting, water boiling, or a puddle disappearing in the sun, remember this: you're not just looking at water. You're watching trillions of tiny particles changing speed, changing state,